Yeah, I'll share the screen now.
Okay.
Okay. So you think these are the returns given by Nifty and ICICI. When Nifty's return was 10, ICICI's return was 13 percentage. When Nifty's return was 15, ICICI's return was again 15. When Nifty's return is -1, ICICI's return is 3. Nifty's return 12, ICICI's return is 12. Now we want to analyze the returns, whether the variances, to what extent the variances are dependent and not dependent. Okay, see, um, let's say, so what we have to find out here is, first of all, R, correlation. Then this is called coefficient of determination. Okay, coefficient of determination, R square. What is this? You will
Okay.
come to know. Coefficient of determination. It's a very lengthy one. Okay, what I suggest is probably you also write along with me.
Okay.
It will be easier, because otherwise this board will be too short for the sum. So
Okay.
then I will keep, scrolling up down, and then you will not get it then. So when you also write, it will be there in front of you, so it will be easier for you to understand that.
Okay.
Okay. Then, so once you are ready for writing, you let me know.
Yes, I'm writing.
Okay, fine. Probably I can fill up all this board first, and then you can write. Okay.
Okay.
Then what we have to find out is SEE. SE is standard error of estimate. So I'll write this little down here. Standard error of estimate. So what is the formula? All you will come to know. Then n. N is equal to easy number of observation, that is 4. Okay. Then we have to do ANOVA table. ANOVA stands for analysis of variance. Analysis of variance. Okay. So here, under this table, we will have degree of freedom. Then here, left hand side, we have regression. What is this? You will come to know in some time. Regression, which is also called as explained variation. I'm using the word variation, not variance. Okay, what is the difference? You will come to know. Then error. Error is unexplained variation. And then total. Degree of freedom, this is SS. SS means sum of the squared. Then MS, mean sum of the squared. Okay, and this is F test. Okay, so this is what we need to find out. So you just, first of all, Uh, see here, give some space. Okay,
Okay.
like 3-4 lines you leave it. Here also 3-4 lines you leave it. Like you can leave 3-4 lines in between all these things, and then you write down all. Because I will be writing here. Okay. So this is the question. Okay. Overall, what we have written is the question. This is what we need to find out based on this Nifty and ICICI. This Nifty is called as variable X variable, and ICICI is Y variable. Why? Because Y is the independent variable. Okay, Y is dependent. ICICI is written as dependent on Nifty. So this
Yes.
is
Yeah.
called dependent variable. And X means Nifty is called independent variable. Independent variable.
Okay.
So you just write down all this now.
Done, sir.
Done. Okay.
Yes.
Written this also.
Yes.
Okay, fine. So now how do I find out? Okay, see, I'm going to use all long cut now. Okay, lengthy way I'm going to explain, but there is a shortcut way also. In fact, this sum can be done in an Excel sheet in just 10-15 seconds also, but I'm going to do this for at least an hour. Okay, so at the end I will tell you the shortcut way also. That means in Excel, plus you can even use shortcut in Calci also. Okay, Excel is the shortest one. Calci is also a shortcut only. But what I'm going to do here is like full long cut so that you understand the background idea. Okay. So number one, R, correlation. You remember the formula for correlation?
Yes.
What is the formula?
Covariance of x and y upon standard deviation of x into standard deviation of y.
Ha, correct. So R is equal to covariance of x comma y divided by standard deviation of x into standard deviation of y. So now, so let me write that here. Covariance of x comma y divided by standard deviation of x into standard deviation of y. So covariance, what is the formula for covariance? Covariance is formula.
Um,
You don't remember?
no, sir.
Okay, covariance of x comma y is summation of x minus x bar into y minus y bar divided by n minus 1. Okay, so what do I require now? I require x minus x bar into y minus y bar the whole square. I mean, not whole square, x minus x bar into y minus y bar. So summation of x minus x bar into y minus y bar. So x's value is 10, 15 minus 1, 12. 10, 15 minus 1, 12. X bar. Okay, so you calculate the average of this.
It's
Take out
9.
your calci, 9. So
Yes.
X bar is equal to 9. What is Y bar?
Y bar 10.75.
10.75. Okay.
Yes.
So 9, this is 9, 9, 9. 10.75. Y's value is 13, 15, 3, 12. 13, 15, 3, 12. So now you calculate 10 minus 9 is 1, and then 13 minus 10.35, and then keep it in store 1.
Okay.
Okay, like this you add up all. This is store 1, store 2, store 3, store 4, and then add up all. You do slowly, it is fine, but make sure you are accurate. Okay.
Yes. So it's 30.50.
30.50, right? Okay. So it will be 30.50 divided by 4 minus 1.
Yes.
Hmm.
10.16.
So covariance. So covariance is 10.16. Then standard deviation of x. So standard deviation of x is, okay, standard deviation of x. So
6.04.
okay, you found out also.
Yeah. So do we see the standard deviation of x or sample of x? Like
Sample,
standard
sample.
deviation.
Oh, you are using what? See,
Uh,
that
yes.
shortcut method.
Yes. So that is
Mm, in the calci itself, you have found out.
yes.
Okay. Uh, x minus x bar the whole square. Okay. Okay, let me but still do it like
Okay.
proper long cut so that you know at any time when you see it becomes easier. If you forget also later on, x will be 10, 15 minus 1, 12. So 10, 15 minus 1, 12. X bar is 9. Square. Calculate.
146.
146. So root of 146 divided by 4 minus 1.
3.
How much?
6.97.
It's the same one, right?
Yes.
That you calculated. Okay. This is standard deviation of x. Now we'll see standard deviation of y. So summation of y minus y bar the whole square. Y is y is 13, 15, 3, 12. Y bar 10.75. Calculate all this.
84.75.
Hmm.
So 5.31.
Okay. So standard deviation of y also we have got. So standard deviation of x is 6.97 into standard deviation of y is 5.31. Calculate this r.
0.274.
Hmm?
0.274.
0.27.
4.
Oh, that much is only the correlation. Okay, fine. So now we'll check using shortcut method. See, in your calci, BA2 plus okay, so here you want to activate this data function. Okay, So second and 7, when you do this upper part, data will get activated. Second 7. So x01, so x variable's value, x value is 10. So 10, enter. Okay. 10, enter. Then downward arrow. Y01 is 13. 1, 3. Enter. Okay. Then downward arrow. X02 is 15. Enter. Downward arrow. Y02 is again 15. Enter. Downward arrow. X03 is minus 1. So 1 minus, enter. Downward arrow. Y03 is 3. Enter. Downward arrow. X04 is 12. Enter. Downward arrow. 12. Enter. Okay. Key in till here.
Yes. Yes, sir.
Then so you have keyed in the number. Now the output, when you want, you have to click on this stats function. So second 8 I will do, so that the stat function gets activated. Okay, so you will get linear in your lin or linear in your this calci. Now you do downward arrow, you will get n is equal to 4. Again downward arrow, x bar equal to 9. You got this one. You can keep cross checking all these numbers.
Yeah.
So here, so it is 9. Okay, then again downward arrow. Uh, this is sample standard deviation 6.98. We can cross check now. Sample standard deviation 6.97. Fine, that is okay. Okay, then this is population standard deviation 6.04, which we don't require because we have taken sample only now. Okay, in case if you ever get confused which one is sample, which one is population, is bigger number will be sample. Why? Because in the sample we will do n minus 1.
Okay.
So the denominator will be bigger, no?
Yes.
Okay. In case if you forget or if you get confused, okay. Then y bar is 10.75. So that is also right only. 10.75. Okay. Then downward arrow. This is standard deviation of y 5.32. So 5.32. 5.31. Okay, fine. This is also okay. So all these are right. Then downward arrow. This is population standard deviation of y, which we don't require. Then what is a, you will come to know in some time. This is at the moment it is not required. B is not required. R is equal to 0.98. So you have done some mistake. Okay, so
I
calculation
think
wise,
covariance was, I will cross check the covariance.
covariance, then covariance should be wrong. Just recheck again.
Okay. So
What happened?
covariance is 36.33.
36.33.
Yes.
Okay. So divided by 3 comes to,
No, the total is 36.33.
oh, overall this number
Yes.
36.33. Okay. So if this is 36.33, now you calculate.
Yeah, 0.98.
Ah, okay. So till here you have written everything, all the steps you have written.
I have to write. I'll write now.
Huh. Okay, so you write down all this.
Done, sir.
Okay. All these are done. This part.
Yes.
All this you have written, right?
Yeah.
Okay. So now we have calculated R 0.98. Okay. Now R square is obviously, 0.98 square. Just calculate this. Why it is like this, we will see in some time.
0.9604.
Now there are other formulas also to calculate this, which is also needed. Okay. So you should know that as well. These formulas, so that also we will know now. See. Okay. Now coming to the regression. See. Uh, Equation of a line is equal to y is equal to a plus bx. Okay, you can also call this as y is equal to b0 plus b1x. That way also you can say b1x1, or y is equal to b0 plus b1x1, or y is equal to a plus bx.
This
Okay,
is equation of line.
equation of a line. Equation of a line. This is the equation of a line,
Yeah.
because this is how y goes. Say for example, see, if I draw a line like this is y. Okay, imagine.
Yes.
So now, not that one, wait, not this one. Okay, so now the value of y, see this is called a, this is intercept. A means the value when this is x and this is y. Okay, a means a's value is when x's value is 0. Suppose if I keep x's value as 0, still a's value will be this much,
Yes.
because all these will become 0. So that is called as intercept. Intercept means, the value of y when x's value is 0. The value of y when x's value is 0, that is called intercept. And beyond that, y is changing based on the value of x, based on the value of x and its slope. Okay, so that's why this is the equation of a line. So it is a plus the way x is moving and its slope based on that. Okay, so now here, let's say, acha, how do I get this white color line first of all? Okay, so say for example, now I am plotting all this. Okay, I'm plotting all this in the Excel sheet, let's say, or graphs. So it will come like this: when x is this number, y is this number. When x is this number, y is this number. When x is here, y is here. When x is here, y is here. Okay, like this, various numbers. Imagine I'm plotting. Understood this one?
Yes.
Okay. So like this, various, here we have taken very simple example of only 4 observations, but practically many observations will be there, right? So when many observations will be there, so it will come like this. And so, and then one regression line is drawn in between. Okay. What do you mean by that regression line? That is also called ordinary least square. Okay, ordinary least square. That line will have minimum variance, least variance between all these observations. Okay, least, so less, in between. It is in between line. Okay. Basically, this is also called regression line. Basically, you are regressing. That means you are going back to the data, and going back to the data, you are drawing, or you are finding one predicted line, or predicting line. You are predicting. Okay, which is exactly with least, ordinary least square means least variances are there. That means you are predicting exactly in between.
Yes.
Okay. So now I'm just drawing the line directly. So let's say that is the regression line. We have drawn one line like this, regression line. And this is called y bar. Okay. So let's say normally this is the returns that the ICICI Bank gives. This return. Okay, normally average. But this time we have predicted that it will give us this much return. Okay, you can see it is used in many fields. You can even connect this with returns of your stock, or you can even connect this with sales, okay, of your company. So we are predicting average sales, but now we are, no, this is average sales, but we are predicting this much sales, maybe because of season, festival season. Okay, so that prediction is called y hat. So we have predicted based on, as I said, all these data points. We have predicted that this much should be the one. Okay, and but practically, will it be the one? No, there will be some differences. So practically there will be some error. So
Yes.
practically, imagine this is y. This is the actual y. So y
Okay.
bar is normal average sales or average returns. Y hat is the predicted return or predicted sales. Actual y is the observed y. That means actually that much sales is happening, or that much returns the company is giving. Okay. So So that means this regression line is helping you to at least come from y bar to y hat. Na? At least this much it is helping you. And also it is giving you some error as well. It is not able to predict very accurately. This part is called error. Error, right?
Yes.
And this part is called uh, error. This part is called explained variation. Explained variation. That means regression. And this error is also called unexplained variation. So this explained variation is also called regression. This is called unexplained.
So, is the goal to reach the observed y? To be closer to the observed y, right?
Yes, yes, correct. Okay. And this y minus y bar, this is called total variation. It's a total change, total variation, total variation. Fine, okay.
Yes.
So now we have to calculate this data first of all. Y hat minus y bar minus y hat. Okay, see now we know that y minus y hat, y minus y bar, if I try to find out, I will get the summation, I will get 0. Okay, see here. Now why did I take square over here? Because if I don't take square, I will get all 0 only.
Yes. Yeah.
You know this, right? Or you want to check?
Yeah.
You want to check?
Yes.
Okay, see. Summation, why did we take square here? Otherwise, I will not get any variation. See, y minus y bar, if I do 13 minus 10.75.
Two point two five.
How much?
2.25.
2.25. Okay. Then 15 minus 10.75. This is minus
4.
2.25. Okay. No,
Yeah.
no, no. Sorry. This is plus. This is bigger number. Sorry, sorry. 10 point 10.75. Ah. So you don't take square. How much is it? 2.25.
2.25.
15 minus 10.75.
4.25.
4.25. Then 3 minus 10.75.
Minus 7.75.
Minus 7.75. 12 minus 10.75.
1.25.
Add up all this.
0. Yeah.
It will come to 0. And that is why we squared it.
Yeah.
Okay. So
Yes.
here also, because this will come to 0, so what will I do here? I want this total variation I already know. How? Because it is already here, y minus y bar,
Yes.
84.75. I have already got it. Okay, but it is in squared form. So similarly, I want, so these are all the parts. So this also I want in squared form, y bar minus y hat the whole square. Y bar minus y hat the whole square. So that will be y bar is what? 10.75. No?
Yeah.
10.75 y hat. Acha, y hat, how do I know? Okay, so I need to calculate y hat. So to calculate y hat, okay, Uh, just 1 minute. I'll connect the charger to the laptop. Okay. You have written this part.
I'll write it.
You can write it in the meanwhile.
Yeah.
Yeah. Written.
Yes, sir.
Hello.
Hello. Hello.
Hello.
Yes, sir.
Hello.
Hello.
You have written it.
Yes, sir.
Okay. Okay. 1 minute. You are not able to see the screen now.
No, sir.
Can you see the screen now?
Yes.
So y bar minus y hat. So acha, y hat, how to calculate? So how to calculate y hat? See, we know um, y is equal to a plus bx. So therefore, y bar is equal to a plus b x bar. Hmm. Okay, and also, so if this is the case, y bar is equal to uh, yeah, and this b is uh, okay, b is beta. Okay, this is beta. So beta is equal to, there is a formula for this b. covariance of x comma y. X comma y means nifty. Nifty means market comma stock divided by variance of the market. Variance of the market. So we already know covariance. Covariance is 30 point something. We said, right? Covariance is
36.33. Yeah.
36.33, right? This one. So 36.33 divided by variance of the market. That means we have to get standard deviation of x first. So standard deviation of x is
6.97.
6.97. So you square this, you will get variance, right? Square
Yeah.
this 6.97.
48.5.
48.5. Okay. Calculate this beta.
0.749.
0.749.
9. Yeah.
Okay. So we have got beta 0.749. Okay. So now, so we know beta also. Okay. See, now we know y bar and x bar as well. So we can calculate a. Y bar is equal to what? 10.75, na? Y bar.
Yeah.
10.75 and 9. Okay. So 10.75 is equal to a plus 0.749 into 9, correct? X bar is 9, right? So now you calculate
Yes.
the value of a.
4.03.
Okay. So we have got a, we have got b's value also. Now predicted value, okay, is equal to a plus bx. That means based on x, what should be the value of a? Say for example, first predicted value. A is what? A is 4.03 plus B is 0.749 into x1. So x1 is, for this value, for this is x1, okay,
Yeah.
10. So for 10, actual value is 13, but what should be the predicted value? Predicted value. Uh, hmm, hmm. What is the value of x, Biswa? Value of x was 10, right?
Yeah.
10. 10 only, no?
Yes.
Okay, so what should be the predicted value in that case?
11.52.
11.52. That means when x's value is 10, we predicted it should be 11.52, but actual value was 13, correct?
Yes. Yeah.
Actual value was 13. Okay, so that remaining part is the error. So if this is Okay, if we are predicting 10.10 11.52, no, if you are predicting 10, if you are sorry, if you are predicting 11.52, y's value comes as 13. Is it okay?
So if
Hmm.
so based on x's value, we are predicting y's value.
Yeah.
Okay.
The actual y is different. The actual y is 13, but we predicted 11.52.
Actual value will always be higher.
No, not necessary. But in this case, I have taken it like this so that I can standardize.
Okay.
Okay. So that it becomes easier also to understand. Okay. Just hold on 1 minute. Huh? Hello.
Yes.
Yeah, I'm so sorry. Yeah. Okay. So yeah, so this is 11.52. Now, predicted value for x2. So when x2 was, what is the value of x2?
15.
X2 is 15, right?
Yes.
X2 is 15. So 15. Now you calculate
15.26.
15.26.
Yes.
Okay. And the actual value was
15.
15. Okay. Yeah. So now here minus 1 and 12. So minus 1 and 12. Minus 1 and 12.
3.28.
3.28. Okay.
13.0.
13.0.
Yeah.
Okay. So these are the predicted value. So now based on this, so predicted value is 11.52, 15.26. So 11.52, 15.26. Then 3.28. And then 13. Hmm. Let's calculate all this.
Yes. 53.706.
53.706. Okay. So this is called what? Explained variation. See, I'm using the word variation, not variance. Why? Reason being, variance will have denominator as n minus 1. Can you understand this one? It has
Yes.
only the numerator part of variance. So variance's formula is what? Variance is summation of x minus x bar the whole square divided by n minus 1.
Yes.
Okay, this is the formula for variance. Variance. Okay, now because I'm taking only the numerator part, that is called as variation. Okay, variation. Now similarly, now next one is unexplained variation. So this is explained variation or regression. Now unexplained variation. Unexplained is what? Y hat minus y, y hat minus y. Okay, y hat. See, you take y hat minus y whole square or y minus y hat the whole square. It's one and the same. Okay, because we are squaring, right? So we don't have any minus problem there. So here I'll write y hat minus y the whole square. y hat minus y. So y hat, I'll write all this y hat. This is 11.52 minus this is 15.26. Y's value, y is y is 13, 15, 3, 12. 13, 15, 3, 12. 13, 15, 3, 12. 13, 15, 3, 12. Calculate now.
3.33.
3.33. That's it.
Yes,
Okay.
3.3.
Okay. So adding this comes to how much?
57.036.
Now that should match. No, it is wrong. It cannot be so low. You have to calculate again. Tell me the first one. This is 13. 11.52 minus 13 square.
2.190.
2.19. Okay. Second one, 0.26, right? 15.26 minus 15.26 square is how can
Point
it be
zero
2.1 and 12, 13, 4? 1 second, wait. 11 point. Eleven point 52 minus 13 square. Okay, it comes to 2.19 only. Okay. Then 15.26 minus 15 square.
0.067.
uh, 0.067 store 2. Then 3.28 minus 3 um, square. 0.078. Then this is 1 square is 1. Still it is very less. Recall 1 plus recall 2 plus recall 3 plus recall 4. How much is it?
3.336.
3.33. Okay, something has gone wrong in the calculation, but we can find it out. See, so it is still there. Yeah. So here, okay, we can check all this A first of all. You come to this calci A, is it matching 4.03? A intercept 4.03 matching, right? So this is okay. Downward arrow B is 0.75, that is also matching 0.749. Okay, then downward arrow R is 0.98 is okay. Now how to calculate this predicted value? X's value is 10. Okay, if X's value is 10, what is the value of Y? So X dash is for X's value is 10, right? So you keep 10 here, enter. Then you do downward arrow. Then Y's value we have to predict. So you click on compute. Just try. I'm not able to do this here. I don't know why,
This is,
but you try in your calci, you should get it.
this is 11.50.
So it is showing 11.50. This is matching. Then similarly, now what you do is again you do upward arrow, go back to that X, and there you type 15. Then enter. Then you come back downward arrow. When you get Y, click on compute. What do you get?
15.22.
15.22. Okay, this is also okay. Then similarly, you again do upward arrow, go to X, type -1, and then uh, downward arrow, come to Y, click on compute.
3.28.
3.28 is okay. Similarly, calculate for 12 also.
12.98.
Okay, so that is 13. So this predicted value is fine only. Then is there anything wrong here? Y minus Y bar. No, this cannot be wrong because this is right. So this is right, 84. Then is this wrong then? Okay, let's calculate this one only. Y bar is 10.75, is it?
Yes.
Y bar is 10.75 only.
Yeah.
Yeah, that's right. Y hat. Okay, let's calculate this quickly. I'll also calculate. 10.75 minus 11.52 and then square 0.5929. Okay, I'll keep it in store 1. 10.75 minus 15.26 square 20.34. And third one, 10.75 minus 3.28 square store 3. 55 point. Here is the difference. 55.8. Okay, store 3. 10.75 minus 13 square 5.06. So now I'll add Recall 1 plus recall 2 plus recall 3 plus recall 4. 81. 81.79. Na?
Yes.
Now it is fine, right? 81.79 plus 3.33 you do
85.126. Yeah.
85 point. So which is okay. One number 1, 2 is fine. All decimal thing. Okay. Understood this one?
Yes.
Okay. So now we have got all the numbers now. We just have to plug in now here. Okay. Now degree of freedom. Degree of freedom for level 1, it will always be K. K stands for number of independent variable, and for you for level 1 there will be only one independent variable. For example, in this case Nifty is the only one independent variable, because this is called simple linear regression. In simple linear you will have only one independent variable. That means ICICI is dependent only on Nifty. But in level 2 you will learn multiple linear regression, where ICICI is dependent on Nifty, plus it may be dependent on interest rates and other variables as well. That is multiple linear regression, but here for you there is only one. So K represents number of independent variable, so it will always be 1 for you, level 1. Okay,
Okay.
number of independent variable. Number of independent variable. Okay, K. So that is equal to 1 always. Always 1. Here degree of freedom is n minus K minus 1. So n is 4 minus 1 minus 1. In other words, I can even say n minus 2. Degree of freedom is n minus 2. Okay, so that is equal to 4 minus 2, that is equal to 2. Total will be 1 and 2, 3. So you write down till here. You have written down all the remaining thing here. You have written down all this.
I'll write it down.
Written, right?
Yes.
Okay then. So now sum of the squared SS. See how you have to read this is SSR. Okay, in the book also this is how it is mentioned. SSR, sum of the squared regression. So which is what? Explained variation. So what is that total? 83 something you said, right? 81.79. Okay, this is explained variation. 81.79. So 81.7, or I'll write properly. Instead of directly writing 81, I'll mention here this is equal to summation of y bar minus y hat whole square, which is 81 point. What is that number?
81.79.
79.
Yeah.
Okay. Then error SSE. This is written as SSE, sum of the squared error. Okay, sum of the squared error. Now that is equal to what? Summation of y hat minus y the whole square. Correct?
Yes.
How much is that? 3.33,
Three
right?
three. Yeah.
Now adding all comes
85.
to 8. I'll just write this one what we have calculated. 84.75. Okay,
Yes.
total. That 1 or 2 points is okay. There's a decimal is not going to affect. 84.75. Okay. Hmm. Now mean sum of the squared error. Mean sum of the squared error. Mean sum of the squared regression. So that is equal to, that means MSR. Mean means what? We have to divide it by degree of freedom. So that means the formula goes like this: y r minus y hat square divided by degree of freedom. So that is equal to 81.79 divided by 1. So this number will always be equal to sum of the squared regression. Can you understand why? Because here denominator is 1, right? That is the
Yes.
reason.
Okay.
So you should know this one, because again they might give you mean sum of the squared and they will ask you sum of the squared. SSR is what? So both will be equal only. Okay, both will always be equal. Is it okay?
Yes.
The next one is MSE. So MSE is SS SS SSE divided by uh, degree of freedom. So SSE is what? SSE is the 3.33 divided by degree of freedom is 2.
1.66.
Now you add these two.
83.45.
80.
3.45.
Okay, right. So we have filled up all this. Now F test. Basically, what is F test? In F test, what did we see in F test? F
Variances.
test is variance by variance. That means we are checking
Yes.
whether variances are significantly different or not.
Yes.
Okay, variances are significantly different or not. So here also we are doing the same thing, but the formula, actually it is the same formula only, but I'm writing it in another format. Okay, here the formula is MSR by MSE. Okay, why it is like this, you will come to know. It is actually variance by variance only. Okay, so MSR is what? This is MSR. MSR will be 81.79, correct?
Yes.
81.79 divided by MSE. MSE is this one, 1.66. Just calculate this.
49.27. 27.
49.27. Okay, 49.27. So why the formula is like this? If I elaborate this formula, what is MSR? MSR is summation of y y bar minus y hat whole square divided by degree of freedom divided by summation of divided by uh, this also. See, I can write this as SSE is summation of y hat minus y the whole square
Yes.
divided by degree of freedom. So summation of y hat minus y the whole square divided by degree of freedom. Okay, both the degree of freedom are different. Okay, but you see now this is taking the shape of variance by variance.
Yes, sure.
Okay, so that only shortly I'm writing MSR by MSC.
Okay.
Okay, so which is 49.27. Now, uh, so I will go and check the F test table. So it is right side. So I'll open F test table now. So here, numerator, what is the degree of freedom? Degree of freedom for MSR, it was 1 always, right? 1. And this one is 2, no? Degree of freedom. So numerator along the top row, so 1. And denominator along the side row, right? So 2. So this is 18.5. Yeah, 18.5, right? So 18.5 is the critical value, and it is falling outside the range. Okay, so that means null will be what? Null will be no difference in variance equal to 0. No difference. No difference in variance. Okay, alternative is what? Not equal to 0. That means difference is difference in variance. Difference in variance. So we will reject null. So difference in variance. Okay, fine, understood. That means there is a vast difference. Okay. So such data is a good one only for us because it shows for every, see, if I logically think this is my unexplained error and this is my regression. So for every one error that I'm getting good amount of 49 is what explained one. So that means my error is very less in comparison to what I'm able to predict. So this data is good. That means okay. So till here it is fine. You want to write all this?
I've written it down.
You have written it down already. Okay. Then further we'll fill up all this. Now R square. See, there are multiple formulas for this, which is coefficient of determination, which is calculated as explained variation divided by total. So explained variation is how much? 81. No, it was
Yeah,
how
81.7.
much?
81.79.
81.79. 81.79, and total is this one, 84.75. 81.79 divided by 84 point.
I don't remember.
You have not written it.
84.15.
84.15.
0.971.
So that is, I'll write this one only 96, okay? So that matches. Otherwise, or there is one more formula, 1 minus unexplained variation divided by total variation. So that is equal to 1 minus unexplained is what, 3.33
Yes.
divided by total variation is 84.15. Calculate this now. You should again get 0.96.
Yes, sir.
Yeah, okay. So you should know all these formulas because you never know how the question will come. They might give you unexplained and total variation and then ask you to calculate R square. Then you have to use this formula. Okay. So this is also done. So basically what is R square? R square means, see, R is telling you the strength of linear relationship. So 0.9698 is what? Very strong linear relationship. That means when X is going up, Y is also going up. That
Yes.
is what R is telling you. R square will tell you what percentage of Y is explained by X. That means how much of movement of Y is happening because of the movement of the variable X. So here 96% of the movement in Y is happening because of the variable X.
Okay. So it's
Okay.
telling the intensity of the
It,
difference.
it is more accurate. This is R is telling you the intensity. R is telling you, like, if X is going up, Y will also go up. R square is telling you how much.
Okay.
Okay. So because R can range from -1 to +1, na?
Yes.
-1 to +1. So I cannot say, like, minus, when it goes into minus, I cannot say when, I mean, it doesn't fit in that, if I say minus zero point 0.5, now I cannot say when X is going up, uh, you understood, I cannot say minus 50
Yeah.
percentage Y will go. Minus 50 percentage I cannot say, no, probability cannot be in minus.
Yes.
Whereas here, no, that's why I'm squaring it. So now I can say 96% of the time. Okay, so whatever happens in Y, 96% is explained by X.
Okay.
Fine. Then standard error of estimate is nothing but standard deviation of the entire model. This is the standard deviation of the entire model. So standard deviation of the entire model. So standard deviation of the entire model is the formula is root of MSE. Root of MSE. Okay, root of MSE means what? Now again, MSE, again, it's the same thing, standard deviation only. MSE means what? This is MS and E. MSE. MSE is uh, so MSE is SSE divided by so SSE is this part. Okay, let me write this one. Y hat minus Y raised to 2 divided by degree of freedom. So y hat minus y raised to 2 divided by uh, degree of freedom. Okay, so this is taking the shape of what standard deviation now?
Yes. Yeah.
So root of MSE. So MSE is what? Very less error it was, 3.33. So root of 3.33.
1.82.
1.82. That's it. Understood till here?
Yeah.
So see, in level 2, what happens is, beyond this, what you do is, once you know that okay, there is a match between these numbers, this number, this, because of Nifty ICICI is moving, then you will try to predict what will be Nifty, and so if Nifty is this, what will be ICICI. Those, further predictions, those all will happen in level 2, which is out of sample prediction. That means these are all sample has been given to us. These are all in sample predictions we have done, because we already know, no, what is the actual value of y. All this we already know. But what if I want to predict for the next year? Those part all will come under level 2. So right now, what we are finding is whether this data is good enough, to study or not. And what we have figured out here is, because it is significantly different from each other, then that means difference in difference in variance, which is good. Okay, this number is good. 98 percentage, 96 percentage of y is explained by x, so number seems to be all fine now. Okay, now this, if I have to do this in Excel, this entire sum. Okay, so see, practically, again, when you practice later on, maybe once twice you want to practice all this A to Z, all this in the long cut one. After that, you can use that shortcut calci also to do all this. Okay, why I did all these long cut ones, so that you don't get any doubts like how these numbers are coming. That is the reason. Fine, okay. And so otherwise you can practice with calci, okay. But then I'll tell you uh, the shortcut also. Shortcut as in Excel. So you will not be able to do in Excel in the exam, but then just to give you an idea. It's taking time. But here you have written it all.
Yes.
Okay. You have any questions on all this?
No, sir. Sir, can we do one more sum on this next time in the long cut method only?
Okay, no problem. Yeah. You also practice. Okay,
Yes.
you just practice this, and then once again, then I'll do this. And then, we will go to the book, and then, and then you read the book also. You will be able to understand most of the things. And then when I will take you through the book, it will become easy.
Okay.
Okay. So let's say this is Nifty, this is ICICI. So Nifty is written 10, 15 minus 1, 12. 10, 15 minus 1, 12. 13, 15, 3, 12. 13, 15, 3, 12. Okay. This is X and this is Y. Okay, so after this, all I have to do is come to data, then data analysis, then regression. Okay, Y range. Y is this part, right? Okay, Y. And X is this range. Okay, and then 95% confidence interval it will automatically take. If I want to change, I can change, but let it be 95% only. From where do I need output? Output I want it from, let's say, if I want it in a new Excel sheet, I'll click here. Otherwise, here only, from which cell. So I want it from here. So from here I will get the output. Okay, that's it. Then I'll click on Y. Sorry, I'll click on OK. That's it. See, we have got the numbers. So this is multiple R. R means multiple R. R square. Adjusted R square is not there for you in level 1. It is there in level 2. Okay, standard error 1.29. You can cross check all these answers. 1.82 we got. That's okay, fine. Okay, 96. This is fine, no? 0.98. Okay. So sum of the squared 84.75 also we got.
Yes.
Okay, so in Excel it hardly takes few seconds only. Okay. Fine, okay.
Yes.
Okay, all right, then we'll stop now here. You just practice this once, and then next time we will do one more sum like this, okay?
Okay.
Fine, I'll stop now here.
Okay. Thank you
Okay,
so
okay,
much.
bye.